Hello, this is question 15 on your November 2021 paper 2 from Edexcel. So you have to express this thing here in this form when r is positive and alpha is between 0 and pi halves. Give the exact value of r and the value of alpha in radians to 3 decimal places. So remember that this has a particular way of doing it, so you have to learn that. We need to express 2 cos minus sine, so 2 cos theta minus sine theta, as an r cos theta plus alpha. So what we are going to do is we are going to write using the addition formula for the cos this as, so I don't change anything on the left hand side, and then I have r cos theta cos alpha minus r sine, I'm just using the addition formula, sine theta sine alpha for cos of a plus b, yeah, so using that. Cos alpha and sine alpha are just numbers because alpha is a particular value while theta is my variable, yeah. So if you compare the left hand side with the right hand side, the coefficient of cos theta is going to be the same as the coefficient of cos theta. Think that all this is just a number, so we can write that 2 is going to be r cos alpha. And if we compare the coefficient of sine, which is minus 1, is going to be minus r sine alpha, yeah, comparing. So I have minus 1 is going to be minus r sine alpha, and I can just put both positive. And now I have two equations with two unknowns, r and alpha. So I can divide this one by this one to have tan. So if I divide the bottom one by the top one, I have tan alpha is going to be r and r are cancelled, and then 1/2. Tan alpha is 1/2. With the calculator in radians, you find alpha, and they say to how many decimal places? To 3 decimal places. So this is 0.464 to 3 decimal places. And now they ask me the value of r, but the exact value of r. So if I substitute alpha here and I find sine, I'm going to get decimals for r. The way of avoiding that is just thinking that sine square alpha plus cos square alpha, and this is like a trick that you need to remember. Sine alpha is going to be 1 over r, so sine square is 1 over r squared, and cos alpha from here is going to be 2 divided by r, so square is going to be 4 divided by r squared is going to be 1. So from here I have that r squared is 5, and r is going to be root 5, and I'm going to get the positive one because they say r is positive, yeah, so we cannot choose the other one. So these are the first two things they ask. Then they say figure 6 shows the cross section of a water wheel. The wheel is free to rotate about a fixed axis to the point C, which is this one. The point P is at the end of one of the paddles, so it's going to do this, and the water level is assumed to be horizontal and constant height, which is this. Vertical height t, h in meters, is this equation here, yeah, in terms of the time, where the time is t in seconds after the wheel starts rotating. Using the model, we have to find the maximum height of p above the water level. So we have an expression here that has something cos minus something sine, which is what we have here, and that's why they ask us first to do this. So I'm going to use what I did, and I'm going to substitute this expression here with just cos, because otherwise it's very difficult to find a maximum or minimum. But if I have just cos, I know how to do that. So I didn't write it, but this thing that I found before means that I can express 2 cos minus sine, so I can write 2 cos theta minus sine theta as r cos alpha theta plus alpha. R we say is root 5 cos theta plus 0.464. Yeah, so this is helping me to write this expression like this one. So now I have to write h is 3 plus 4 cos 0.5t minus 2 sine 0.5t. If you compare this with what we have, with this one, you see that I have double of this expression, and instead of theta I have 0.5t. So I'm going to write h as 3, and then instead of writing this thing here, I'm going to write 2 times this expression, so 2 times root 5, and cos, and my theta is 0.5t plus 0.464. And now it's easier to find my maximum, because my maximum is going to be when cos of this angle is 1. So my h maximum, or my maximum height, is going to be 3 plus 2 root 5 meters. And I can leave it this way. I don't need to, you can find the value with the calculator and round, but they don't tell us to give in any particular accuracy. Then the value of t when this maximum height first occurs, giving your answer to 1 decimal place. So we have to find the angle that makes this 1. And so I'm going to make cos 0.5t plus 0.464 equals to 1, which means that 0.5t plus 0.464 is going to be 2 pi. And that means that t is in radians, yeah, so be careful. In radians is 11.638 more, but they ask to 1 decimal place, right? T in seconds, so 11.6 seconds. Then, in a single revolution of the wheel, P is below the water level for a total of t seconds. So P is moving, reaches the 0, the water level, and then is below that up to here, so for some time. They ask, find the value of t, so the time that is underwater, giving your answer to 3 significant figures. So what we can find is when t, when the height is 0, because the height is measured from here, so this is like our origin for the height. So when h is 0, and when h is 0 next time, we will find 2 times, so t1 and t2, and then we subtract them. Yeah, so we have to make h equal to 0 to find 2 times. And we have the equation for h, so it should be fine. h0 means that 3 plus 2 root 5 cos 0.5 t plus 0.464 is going to be 0, which means that cos 0.5t plus 0.464 is going to be minus 3 divided by 2 root 5, and I find that that value, so 0.5t plus 0.464 is 2 point, I'm going to make space, 2.306, and the next value is going to be 3.977. But those are my values for this whole expression, so I need to find t. So I'm going to subtract 0.464 and divide by 0.2. So my 2 times, when I do that, t1 is 3.68 something else, and t2 is 7.03. the difference between these two, so these two times are when first P cross the level of the water, T1, and it will pass again at T2. So the difference is what the time that is in the water. So T, and they call it capital letter T, is going to be 7.03 minus 368, and this is 3.3 to 1 decimal place, and it's seconds. So let me write the units. Always when you have this model real life situation questions, I would always write the units, so you know the time is in seconds, so please write seconds. You know the height is in meters, like here, so write meters. Yeah. Then they say, in reality, the water level may not be a constant height. Explain how the equation of the model should be refined to take this into account. So I would say something like these 3, which is a constant, is a height that doesn't change, should change. Yeah, if the water is not completely flat and it changes, these 3 should change. And we have no idea how would that change, so don't overcomplicate. It's just a mark question. So just write that 3 should vary or something like this. Don't make it because you don't know how it would change. Yeah, should vary, and that's enough for that. Yeah, and that's all with this exam question.